You may have heard that the greatest threat humanity will face in the coming years won't be wars, climate change, a supervolcano, a virus, a meteorite, or even an aging population. It will be the lack of antibiotics. It's hard to determine with absolute certainty which of these deserves this rather dishonorable title, but the lack of antibiotics is the most likely to win. And in fact, in recent years, its effects have already started to show. At the end of the 2000s, for example, totally antibiotic-resistant tuberculosis was detected for the first time, and since then it has been spreading. Tuberculosis and quite a few other resistant diseases. The problem is simple. Since the 1980s, the discovery of new antibiotics has stalled, while bacteria have been gaining immunity to all existing classes. So, if the trend continues, in a few years humans will once again be defenseless against one of the greatest threats our species has faced since its appearance. Human medicine would enter the post-antibiotic era, which would mean returning to health standards from several centuries ago. Medicine from the Middle Ages. A simple scratch on the knee, a C-section, an appendicitis, or a visit to the dentist could easily be lethal, and I'm going to be honest with you. In recent years, the spirits of experts on the subject have been very low. We seem to be headed for the abyss. We're not talking about the extinction of humanity, but probably the collapse of modern society. However, in 2020, a ray of hope appeared. An artificial intelligence discovered a new antibiotic, something that marked the beginning of a revolution that could save humanity. Let's see if it can really achieve it. Why is it that something that worked 10 years ago doesn't work today? Is the chemical substance still the same, and are the bacteria still bacteria? Well, as you're probably thinking, it's because of evolution. Antibiotics are like bombs that can only explode if they have the key to the bacterium's lock. Normally, each antibiotic has the exact keys for locks present in one or several species of bacteria. If they didn't have that key, they wouldn't be able to come into contact with them or get inside. So, as you can see, they would become completely useless. And here's the problem. Over time, every now and then, a bacterium appears that has a mutation in the lock. It's slightly different, just a little bit, but enough so that the key doesn't fit. If antibiotics are used to attack its colony, all of them will die except for it. Not only will it survive, but it will also make copies with that mutation that makes it immune to that key, to that antibiotic. Other antibiotics will have the key to the locks of its copies, but there will always be bacteria that end up mutating their locks and surviving. And the thing is that bacteria have infinite iterations, infinite attempts, because they are constantly evolving. But we only have 25 attempts. The number of antibiotic subclasses is known, rigid substances that do not change over time. This is one of the best visualizations of this phenomenon. 4 petri dishes on each side, plus a central one, each with a concentration of antibiotics 10 times more lethal than the previous one. The bacteria are initially grown in the safe plate, and although with difficulty each time they reach the end of the sections, you can see how. It's only a matter of time before one or several bacteria evolve and start a new lineage, with resistance to the new concentration of antibiotics. Some are more successful than others, but in the end they manage to reach the center, which is 1,000 times more lethal than the first plate. This is what has been happening in our bodies over the last few decades. It's terrifying. But why is it so difficult to discover new antibiotics? If we were able to adapt to so many new locks back then, why can't we do it again now? Well, the short answer is that we've already picked all the low-hanging fruit. The thing is, most of the antibiotics we use weren't discovered by humans. They're the product of nature fighting against itself for hundreds of millions of years. They mainly come from fungi. Shortly after the discovery, not invention, of the first antibiotic, penicillin, many microorganisms were quickly studied so we could get our hands on the entire catalog of antibiotics available in nature. In other words, in just a few years, we used up all the knowledge accumulated by the greatest scientist on the planet, nature, over millions of years. And of course, now that its resources are running out, we have to find new substances ourselves, which is something we're not very good at, since until recently we hadn't needed to do it, with the added difficulty that the simplest ones were already discovered by fungi on their own, and we've already used them up. Additionally, there's the resource issue. Discovering a new antibiotic requires a lot of personnel, with extremely expensive laboratory equipment and years of investment. And antibiotics aren't exactly profitable, to say the least. They're not like paracetamol, which you need for life several times a year. Ideally, you take them once and that's it. And if you discover the ultimate antibiotic that kills almost everything, doctors will keep it locked away as a last resort. In any case, there will hardly be any sales for something that needs a lot to pay for itself. They won't be able to pay the salaries of the people who make it. The future is very dark. Well, it was. Because in 2019, an artificial intelligence identified that a drug for treating diabetes, which had been discarded for not getting good results, was actually a powerful antibiotic. It was called Alecaina in honor of HAL, the AI from Kubrick's 2001 A Space Odyssey. Those of you who know the movie will understand why I don't think this is the best idea for a name. In 2023, something very similar happened again with Bausina. This one is effective against Acinetobacter baumannii, one of the 3 bacteria at the top of the WHO's list of priority threats. Today, both antibiotics are in the testing phase to ensure that their use in humans is safe. If everything goes well, very soon they could be prescribed to you. Although I hope not, because I don't want you to get sick, but in case things go wrong, they'll be there. But this was just the beginning. In the last 3 years, with the improvement of generative models, yes, the same kind of technology used by ChatGPT or an image generator, many more candidates have been discovered. There are several AI models that search for antibiotics, but essentially they all work the same way. They learn the patterns that make a substance toxic to bacteria but safe for humans and generate millions of them until one manages to fit into the known locks. Initially, the trend was to test drugs already discovered by humans, but recently it has been found that it's more effective to ask the models to invent substances from scratch. And every once in a while, after many millions, eurekas happen. Although we have to be realistic. Many of these eureka substances never even get tested because they're impossible to create, or simply, it's clear that they're toxic. Of the few that pass the initial filter, most still fail during manufacturing because they're found to be unstable. And with that, we reach the tiny percentage that actually begins testing in mice. Careful, we're not talking about rediscovered molecules like allicin or Bausina, but about substances created from scratch by AI. Of these miracles, for now there's only one. DN1, which is not only effective but also very different from all classes of antibiotics known so far. So it could be very powerful. Trials have begun, and although a single discovered substance might seem like little, this one is more than enough. More than enough to prove that the method works. That the new and definitive revolution of antibiotics is already here, just in time to save humanity from its greatest threat. Thank you very much for watching the video, and goodbye.